Hey, in this video we're going to check out a way to reverse a list in Prolog, and it's going to basically follow the same strategy as the previous video where we summed all the elements in a list. So we're going to use tail recursion again, and we're going to make use of an accumulator variable to store the progressive result. And we're basically just going to start off by, this is what essentially our query is going to look like when it's written in the console, just so we can get a better idea. So we'll provide a list here, and then this will be the variable that stores the final result, which will be 3, 2, and 1 in the opposite order. So essentially we want to follow the same strategy. So before, we want to isolate the head and tail separately. So the first step that we want to do is the initial head will be 1 and the tail will be 2 and 3, and then we just want to start by setting our accumulator to be, instead of just being 1, we actually want to put it into a list containing the element 1, or the element that which represents the head, and we'll see why we want to make it a list in a second, but it's important to put it inside a list. And that's pretty much it for this part. Then we just, recursively call ourselves again. This time passing in the tail, because we want to progressively make progress to the base case. So we pass in our tail. That means that the head for this new call is going to be 2. The tail will be 3. And here we want to essentially append 2 to the previous accumulator 1. So it's going to look like this as the final result, because it will add it to the head. You can see it's being built in reverse order. So what this actually means is that we want to set up some syntax that combines the two together. So we've got our head, which will be 2, and then we want to combine it with the accumulator, and we use the bar operator again, which is going to merge the two together. So if this still seems weird, I'll write it out in full, which is what it represents. So what we're going to have here is, we'll have 2 representing the head, then we'll have a bar, and then the previous accumulator above us has the value of the list 1. So this is what it looks like now. And if you've seen my unification video, I've talked about the different ways the bar operator can be used. So when you've got a bar with a list following it, that means that the bar removes this list and unpacks the elements inside it. So what this means is that this whole thing reduces or simplifies to just contain 2 and 1, because the bar removes the inner list and unpacks the elements. So that's how we get this result. So that means that the next call will just simply pass in the tail again. Therefore the head is just 3 and the tail is an empty list, and the accumulator is going to be 3, 2 and 1 now, because we're just going to add 3 to the previous accumulator of 2 and 1 by using this syntax here. That means we basically finally arrive at our base case. So basically just recognize that the tail is empty now, so it's probably a good idea to bind the first argument position, match the first argument position to an empty list, and then the only other thing we need to do is basically bind the accumulator to the final result. And the final result is going to be represented as this variable here. So we need to bind this to this and it's going to work exactly the same way as the previous video. So it's just going to be reverse lists. We'll match the empty list argument 1, then we'll pass in the accumulator to the second argument, and then just merge it across to the third argument position, which will have the effect of shoving in the third argument position the level above it, which will cascade back up to the original query. So let's just start working through this. So yeah, like before, we don't want the query to be written, we don't want the query caller to have to provide the accumulator variable, because if they did this, then they could really write any accumulator they wanted, which then it would start to turn into more of an append operation, because then would be appending this onto this. But we don't want that behavior. We purely just want to reverse a list. So we need to have fine-grained control over what our accumulator is initially going to be. So we need to abstract this away again, and we can do this by just creating a rule that accepts a list and has the second argument as the final result, and then we'll just call another helper rule that takes in the head of that list, takes in the tail of that list, and then we'll provide the accumulator here for it, and then we'll just pass through the final variable that the result will be binded to. So because we want to extract the head and tail again, instead of having this as a list, we can just use the head and tail bar notation. So this will give us 1, and the tail will be 2 and 3. And our next call, we want to pass the tail in to this level here. That's why we provide that as the first argument. And we need to give the initial accumulator value here. So we want the initial accumulator value to be the first element inside a list. So we can simply just wrap the head in a list here, which will give us the list 1. And then we just need to go ahead and implement this. So you can think of this as the function call, and this is the function implementation, even though prolog does all these things as rules. I just like to think of them that way. So this here is really a list. It's just a list containing the previous tail. This is going to be the accumulator, and we just pass through the reverse list here. And again, we want to extract the head and the tail out, so we do this again by just using the head and tail notation. And we want to grab what we want to do is we want to merge the head with the previous accumulator value. So the head's going to be 2, the accumulator will be the list 1, so we want to combine these two together. So you can do this in sort of 2 steps, or you can do it in 1 step. So our next call will be using the tail, which will just be 3, and then we need a new accumulator which will store the value of 2 and 1, and then we can just simply pass through the reversed list again. So when you think about what this value is representing, it's really just what I've written here, because we just need to merge the head with the accumulator. So you can write this all in the same place, which will do the same thing. So it's quite convenient to write it all in the one place, and you'll see this a lot in prolog, so it's sort of best to get used to it. If you see anything in the same place, it means it just evaluates it all in the same spot. So that's pretty much done, because now this will be the accumulator 2,1 will be what the next lower level uses to append or concatenate 3 with the previous level accumulator to get this. So then, yeah, we call ourselves again. The tail gets passed down to here, so the head's 3. The tail is now an empty list, and then we just combine 3 with the previous accumulator value of 2 and 1, so we get the new accumulator is 3 and 2 and 1, which is the final answer. So now we just need to do the base case. So we can just declare this here using the same name as before, and we want to have the first argument be an empty list because the tail here is going to be what's called again, but it's empty, so we need to match on that. And the accumulator is just going to be the same, so this will pass 3, 2 and 1, so this will be binded to this value. They're the same name, so 3, 2, 1 list will be binded to this accumulator, which therefore will end up binding to the above the variable above it, because when prolog unifies two unbinded variables, we'll make sure that they share the same value. So therefore this 3, 2, 1 will be binded to here, which will be passed up to the query caller. And because we're using tail recursion, there's no need to recalculate the result when we go back up. It's already done. So yeah, that looks all completed. So now we'll give it a test run. Just refresh the file and test it out. 1, 2 and 3. Result 3, 2 and 1. And yeah, this will just continue to work for all your values. And I just do a trace to show that what I mean by all these variables being having a relationship with each other. So I'll just clean this up a bit and show you what I mean. So I'll write in a base case again. Accumulator. Right, so all these variables have a relationship. I'll just link them together. And just say, for argument's sake, they all share this value here. And let's just call it, actually I'll call it the proper name that I'm going to use here. So I'm going to call it this memory address here, because that's what prolog's using. Your variable name will probably be different to mine. So what it's doing is, the variable here is going to be the value stored at this memory address location, but as we're doing the recursion on the way down, we're reducing the list and building up the result. So this is the base case here, because it's got the empty list here. So this is when the accumulator gets binded to this third argument position. It's going to give the reverse list the value of 3, 2 and 1. So if you watch this next step, you can see that this shared memory address gets 3, 2 and 1 now, and because all these levels above it are also using this same value, you know, this level, and this level all see the result now, because we're using tail recursion. So therefore it's pretty much just a matter of, this is when recursion unwinds, and then we are finally greeted with the result. So that's a way just to visualize what's happening with that. But like I said, because we're using tail recursion, prolog doesn't need to really keep all these levels above it. Once it binds the final result, then because of this shared memory address location, the query at the end can see it. So yeah, that's just a little intro into reversing lists. Hope you enjoyed the video, and catch you next time.